Hello, this is Vladimir Luzgin. Today we continue studying complex numbers. We will see how to solve quadratic equation in the field of complex numbers. You probably remember that if the discriminant of a quadratic equation is negative, then this quadratic equation doesn't have real solutions. But we extended the set of real numbers into the set of complex numbers. Now, all quadratic equations, even those which discriminant is negative, will have complex solutions. To get complex solution of general quadratic equation az squared plus bz plus c equals 0, we apply the formula which is the same as in the case of real numbers. Just in the equation I changed the letter x into z because for complex numbers you usually use variable z instead of x. So this formula z equals minus b plus minus square root of b squared minus 4ac divided by 2a could be applied to get the solution of a quadratic equation in the field of complex numbers. Example. Solve the following equation. Z squared plus 3z plus 5 equals 0. As usually we apply this formula. So z would be minus 3, it's minus b, plus minus b squared, 3 squared, minus 4ac, a is 1 and c is 5. Divide by 2a, divide by 2 times 1. 3 squared is 9, 5 times 1, 4 times 1 times 5 is 20, 9 minus 20 is negative 11. So under the root, under the radical sign, we have negative number, negative 11. But we can, instead of square root of negative 11, we can write I square root of 11, because square root of negative 1 is I. And we have got the general solution of our quadratic equation. So this equation has two complex roots, minus 3 minus I square root of 11 over 2 and minus 3 plus I square root of 11 over 2. The coefficients of original quadratic equation were real numbers, 1, 3 and 5. This is the reason why the solutions are complex conjugates. You can see that these two numbers are conjugate to each other. Example 2. Determine the quadratic equation whose roots are minus 2 minus I square root of 5 over 3 and minus 2 plus I square root of 5 over 3. Again, you see that the roots are complex conjugates, because the equation probably would be with real coefficients a, b and c. So how to determine, how to restore the quadratic equation with these roots? Let us write these roots this way. Z equals minus 2 plus minus I square root of 5 over 3. So the way as we get it while solving quadratic equation. Now let us do the same way as we did in case of solving quadratic equation, but backwards. So from this equality, by multiplying by 3, we can get the following equality. 3z equals minus 2 plus minus I square root of 5. Now let us move negative 2 to the left side. Don't forget to change the sign into plus. And then we can square both sides. In the left side, we apply the formula square of sum, square of the first term plus twice product of the terms plus the square of the second term. And in the right side, plus minus squared of course gives us plus. I squared gives minus 1 and square root of 5 gives 5. So the square of the right side is negative 5. Now we move negative 5 from right side to the left, and because 4 plus 5 is 9, we get the following quadratic equation: 9z squared plus 12z plus 9 equals 0. Now we can reduce all the terms by 3, and this is our final answer. The quadratic equation with the given roots is the following: 3z squared plus 4z plus 3 equals 0. The lesson is over. Thank you very much for participation in the lesson. Goodbye.